Hello everyone, my name is Matvey Poliszczuk, and in this video I will be going over the MEXT Undergraduate 2018 Physics exam. So I will solve and explain every question. Please note that this is part of a series, and in the Physics 2019 video I give a bit of extra helpful info at the start. But to save time, I'm just going to go right into the questions. So first is question 1, which says, an object of mass m is launched horizontally with a speed v at a height of h above the ground, as shown in figure 1-1. Let theta be the impact angle to the ground and g be the acceleration of gravity. Find the formula of tangent theta. So for this question, you need to know about 2D kinematics. In my case, I learned about these so-called Suvat equations, which you can easily find online. You also could find use in knowing the formulas for kinetic and gravitational potential energy, which are, those are these two equations right here. You can solve the question without using these and only using the Suvat equations, but knowing this makes it a lot easier. And these two equations are generally very important for other parts of the physics exam, so you should learn them anyways. Now, at first, you might be tempted to think that the angle we are looking for is made from a right triangle like this one right here, where one side is the height h and the other side is the distance traveled by the ball, which I called L. But if you look at the trajectory of the ball, which is this dotted red line over here, you'll see the angle is clearly very different, right? The ball has a parabolic path, so its angle when hitting the ground is different than the angle made by the horizontal and vertical distances. So instead, to find the angle that the question wants, you need to use the velocities in the x and y direction. So if we're looking for theta, which is this, then we have to use the velocities. So if you know the velocity in y and in x at the exact moment that it impacts the ground, then you can use that to find tangent theta, right? Because tangent theta is opposite over adjacent, and opposite would be the vertical component of the velocity, while adjacent would be the horizontal component of the velocity. So to start, let's find a v sub y. The initial velocity in the y direction is 0, since the object is launched horizontally. With Suvat equations, the initial velocity is represented by the letter u, which is why this is u sub y. That means that at the start, all of the vertical component of the energy is gravitational potential energy. So the initial energy right here is just equal to mgh. At the moment of impact, all of that energy has been transferred to kinetic energy, right? Since we no longer have any gravitational potential energy because the ball has reached the ground. And so now all this energy has become kinetic, which is 1 over 2 mv squared. So yeah, and conservation of energy, of course, means that the initial energy in the y component is equal to the final energy in the y component, which means that these two terms have to equal to each other. And then if you rearrange this to find v sub y, you can find that the vertical component of the velocity impact equals to the square root of 2gh. Next, we can find the horizontal component, and this one's a lot simpler. Initially, the horizontal velocity is given is v, which is just given in the question. Now, the horizontal component of a projectile's velocity does not change because the horizontal velocity is not affected, does not have any acceleration on it, so it stays the same. So that means the horizontal velocity at impact will also just be v. So of all that, we can find that the tangent of theta equals to the square root of 2gh over v, and that is option A. Next is question 2, which says, an object of mass m is attached to a light spring with a force constant k and a natural length L sub o. The object is moving on a frictionless flat horizontal table with a uniform circular motion as shown in figure 1-2. The center of the circle O is at the other end of the spring. During this motion, the length of the spring is extended by alpha times L sub O from the natural length. Find the speed v of the object. So for this, you need to know the behavior of a centripetal force, which can be calculated with this equation right here. You also need to know how to find spring force using this equation. Also, the reason why it's negative in the spring force right here is because the force is opposite to the displacement of the spring, which is the x value. So if you stretch a spring out, it pulls you back, so the direction of the force is opposite to the displacement. And of course, same if you compress a spring, it'll try to push you outwards. So the mass is moving in uniform circular motion on a flat, frictionless surface. That means that the only net force acting on it is the force moving the mass around the circle. So it looks something like this. So that force right here, F sub s, is centripetal since it's creating uniform circular motion, and it is provided by the spring, meaning the force of the spring is a centripetal force. Here I labeled the spring force as F sub s. So since our spring force is centripetal, it is equal to m times v squared over r. M is just the mass, which is given as m in the question. And also, by the way, it's good practice to consider the direction towards the center of the circle as the positive direction. V is the instantaneous velocity of the mass, which is again just given as v in the question. R is the radius from the center of the circle to the circular path of the mass. The question says that the natural length of the spring is L sub O, and the spring is extended by the length of alpha times L sub O. So the distance from the center of the circle to the mass is L sub O, the original length, plus alpha times L sub O, which is the extra extension. So that's the centripetal force. And of course, the centripetal force is provided from the spring, meaning the centripetal force is just the spring force. So the force in the spring is equal to the centripetal force. So force in spring is equal to negative k times x, where x is the extension of the spring, and k is the force constant of the spring, which is again just given in the question as k. We know the extension of the spring is alpha times L sub O. So the force is equal to k times alpha times L sub O. And it also, if you're wondering why the negative symbol is gone, it's because the extension of the spring is away from the center, meaning it's negative, right? I said earlier that the direction towards the center of the circle is positive. So actually it would look like this. But of course we're multiplying negative by negative, so they just cancel each other out. And also you'll see that I factored out L sub O right here. And just logically speaking, we set the direction towards the center of the circle as positive, of course, so this must be a positive force. So now that we have these expressions that equal to each other, we can rearrange to solve for v. And it equals to the square root of 1 plus alpha times k divided by m, all multiplied by L sub O. Also, the reason why L sub O is outside the square root is because before square rooting both sides, we had L sub O squared right here. So L sub O squared, of course, square root it just becomes L sub O. And so this right here matches option E. So next is question 3, which says a charged particle of mass m and charge q is in a uniform electric field E. Initially, the particle is at rest and then accelerated by the electric field. Find the time for the particle to travel a distance d from the initial location. So for this, you need to know the definition of a force, F equals to ma. And also the force on a charge in an electric field, which is Q times E. You also need to know specifically this Suvat equation, but really, you should just know all of them in general. S is the displacement, U is the initial speed, T is time, and A is acceleration. So we have that the force is equal to Q times E, where Q is the charge given in the question, and E is the electric field strength, also given in the question. And because this is a force, it of course equals to m times A, since force is mass times acceleration. So we can rearrange this to find what the acceleration of our particle is. And so we can then use the Suvat equation right here. So the particle starts at rest, so the initial speed is 0. So we have the displacement, which in this question is the distance d, is equal to 1 over 2 times qe over m, which is just acceleration, right? We just sub this in, times t squared. The question wants us to find the time it takes for the particle to travel a distance d. So we just rearrange this equation to solve for t, and we find that it equals to the square root of 2md over QE, which is option F. Next is question 4, which says, a screen is placed at a large distance L from a plate where two slits S1 and S2 are notched. These slits are separated by a distance of D, as shown in figure 1-3. A monochromatic light from a single slit S sub 0 with a wavelength of lambda, I think, passes through the two slits S sub 1 and S sub 2. Bright and dark interference fringes appear on the screen. Find the distance from the screen center O to the third dark line. So for this question, you need to be familiar with Young's two-slit experiment. It's, I believe, one of the first things taught in optics and is very important. So if you're not familiar with what it is and how it works, you probably should study it just in general if you're preparing for the MEXT exam. And if you have, then you should hopefully be a bit familiar with this this equation right here. So this tells the distance between two bright spots in Young's two-slit experiment. N is an integer, lambda is the wavelength, big D is the distance from the wall with two slits to the wall where the light is being projected, and small d is the distance between the two slits, and S is just the distance between two bright spots. So we want to find the distance from the center of the screen to the third dark line. So when n equals to 0, you have a bright spot directly across from the two slits. So it would look something like this. The two slits would be right over here, and then directly across from it when n equals to 0, that would be a bright spot. Then when n is equal to 1, you have the next bright spot, which is right here. When n is equal to 2, you have the next bright spot after that, and so on. So if these are the bright spots, then the dark spots are, of course, in between them. So you'd have a dark spot right here, you'd have a dark spot right here, dark spot right there, and so on. So yeah, right here, of course, is the first dark spot. It's between n equals to 0 and n equals to 1. So to find the distance to this dark spot, you would have to set n equal to 0.5. Right here is the second dark spot, and n would be equal to 1.5. And then right here is the third dark spot, where n is equal to 2.5. So the question says we're looking for the third dark spot, or specifically in the question it says third dark line, and that is between n equals to 2 and n equals to 3. So for this question, n is equal to 2.5, which is the same as 5 over 2. So if we plug that into the equation, we get that the distance s is equal to 5 over 2 times lambda times L all over small d, which is option F. So next is question 5, which says, an observer is moving away at a constant speed of 5 meters per second from a speaker which is emitting sound waves at a frequency of 660 hertz. The sound speed is 330 meters per second. When the sound source S and the observation point O are located as shown in figure 1-4, what frequency of the sound will the observer hear? So for this, you need to be familiar with the Doppler effect, and specifically this equation right here, which tells you the perceived frequency, which is f prime, of a moving observer from a stationary source. So v is the speed of the sound wave, v sub o is the speed of the moving observer, and f is the original frequency. However, the important thing is that v sub o is not just the speed of the observer in any direction, but the speed of the observer relative to the speaker. So the observer might be moving to the right at a speed of 5 meters per second, like what's happening in our question. But because that movement isn't completely perpendicular to the speaker, the observer's relative speed is actually less than 5 meters per second. To find that relative speed, we need to consider the horizontal and vertical distances, which the question gives, but also the direct distance from the speaker to the observer. So you might have already learned, or at least heard of, how you can use a derivative to find the rate of change of the observer's relative position. But thankfully, because it's asking about a specific moment in time, we don't actually have to do that derivative. In my case, that was only taught in university, so at least if you're from, or if your curriculum is similar to mine, I don't think you'd be expected to know how to do that. So instead, we just need to find the ratio of the observer's horizontal distance from the speaker and the total distance from the speaker. That's because the observer is moving perfectly horizontal already. So the horizontal distance is 9 meters as given in the question. And then if we use Pythagorean's theorem, we can find that the total distance right here, L, is 15 meters. Also, you might recognize that this triangle is just a scaled up version of what I like to call the 3, 4, 5 triangle, which is where if you have a right triangle with legs 3 and 4, the hypotenuse will always have a length of 5. This is just that, but 3 times larger, right? We have 9 here, 12 here, and so L must be 15. So now if we take the speed of the observer's motion and multiply it by this ratio of 9 over 15, where 9 is the horizontal distance and 15 is the total distance, we get that the relative speed of this observer from the speaker is 3 meters per second. And to be clear, that's only at this exact moment when the horizontal distance is 9 and the total distance is 15. If you wanted to find a general equation for it, you would have to do a derivative. But again, thankfully, this question doesn't want us to do that. Instead, we just need to do find the horizontal and total relative to each other at this exact moment. Yeah, so if the relative movement thing here is a bit confusing to you, then I highly suggest studying the Doppler effect. It shows up several times in the former exam, so it's definitely something that you need to study. And it's actually not that difficult in my opinion. It's a pretty straightforward topic. But if you just want to know how to answer this question, then the important thing to know is that since the observer is moving perfectly horizontal, its relative speed at a specific moment is the ratio of its horizontal distance to total distance from the speaker. So since the observer's actual speed is 5 meters per second, multiplying that by the ratio 9 over 15 gives us that the relative speed is 3 meters per second. So now we can plug in the values into the formula I gave earlier. So the original frequency is 660 hertz. The sound speed is 330 meters per second, and the relative speed of the observer is 3 meters per second. So now I just need to do a bit of math. Oh, sorry. Sorry about that. There was some noise going on outside. But yeah, so now we can plug in the values. And so then you just do a bit of math. It's a little bit tricky because you don't get a calculator for this exam. But with a couple of tricks, you can make it a lot easier. So 660 and 330, so these two values right here, can both be divided by 10 to become 66 and 33. And 66 is clearly just double 33, so 66 over 33 just becomes 2. So then we just have 327 times 2. You do, and hopefully you know how to do multiplication on paper. You can find that equals to 654 hertz, which is choice C. So next is the section 2 question, which says, the region on the right-hand side of line XY is filled with a uniform magnetic field of flux density B, pointing out from back to front as shown in figure 2. A square coil ABCD with a side length of L enters the magnetic field region with a constant speed V. Line XY and side AB are parallel to each other. The resistance of the coil is R. At a time t equals 0, side AB of the coil passes a line XY. Answer the following questions in the case of 0 is less than t is less than L over V. So this is a question about magnetic fields. There's a number of things that you need to know to be able to answer this question, but really it just boils down to having learned the physics chapters on electric and magnetic fields, including wires in magnetic fields and the forces introduced. As far as I'm aware, these concepts are normally taught pretty early in the unit. So if you study high school level electric and magnetic fields, then you probably should be able to answer this question. But here are the specifics. So this equation right here is used to find the magnetic flux. So it's the perpendicular area of a coil in a magnetic field times the flux density. There is also these equations. QE is the electric force on a particle with charge Q in an electric field of charge E, and QVB, is the magnetic force of charge Q moving with a perpendicular velocity V through magnetic field B. They equal to each other because our coil is moving at a constant speed v, which means there is no net force. And this is what you will usually see in a question like this, where you have like a coil or just a conductive material passing through a magnetic field. So you cancel out Q on both sides, and then you multiply both sides by L like this. And so, and L is the distance between the top and bottom of the coil perpendicular to the magnetic field. And you get that VBL is equal to the induced EMF, or electromotive force, in volts. That's because it's work done on charges. We found the force on the charge, and we multiply it by the distance the charge passes through, which is work, and volts is, of course, work. Again, volts is work on charges. So again, this is probably a lot to take in if you haven't studied electric and magnetic fields before. So if you haven't yet, then I would suggest just leave this question until you have. I'll do my best to try and introduce these concepts right now, but it's this kind of stuff isn't really like intuitive or obvious if you haven't studied this topic before. Now, so hopefully you all know that voltage is equal to current times the resistance. After that, an important thing to note is that an induced current flows such that its magnetic field opposes change in flux. So what that means is that if a wire or a coil enters a magnetic field with conditions to create an induced current, that current, which produces a magnetic field of its own, will flow such that the magnetic field that it produces will oppose the change in flux from the magnetic field that it is passing through. And magnetic flux is directed along the magnetic field lines. In the question, it tells us the magnetic field is pointing out from the back of the page to the front. And so if you know this, you can find the direction of the current using the right-hand rule, which tells you what direction is an induced field is pointing based on the direction of the current. Finally, you need to know this equation, you need to know the right-hand rule, which I just mentioned. You need to know this equation right here, which is the magnetic force on a current carrying conductor, in our case, the square coil, in a magnetic field. So yeah, if you haven't learned about this stuff before, then unfortunately, I don't think there's any getting around just studying the entire topic. In my case, it was just, a bit of memorization. As much as the material isn't very intuitive, in my opinion, it's kind of abstract, but it's high school level. It's not that difficult or confusing, in my opinion. But with all that out of the way, we can start answering the question. So first is part 1, which says, find the magnitude of the magnetic flux which passes through the coil at the time t. So the magnitude of magnetic flux is given by this equation right here. B is given to us, so we need to find the area of the coil, A, right here, inside of the magnetic field. So given that this is a rectangle right here, the area is the base times the height. But of course, we only want the area inside of the field. The question says that when t is equal to 0, side AB, which is the right side right here, passes line XY, which is the line at which the magnetic field starts. So at time t equals to 0, the coil enters the field. Since the coil is square and is moving in a straight line to the right, the height of the coil inside the field will always just be the distance from point A to point B, which is just length L. So height, which is this right here, this is the height, will just be length L. So now we just need to find the base in terms of t. So the coil is moving with speed v, which means that after a certain amount of time, its distance traveled is v times t. Like if you're moving at 5 meters per second for 2 seconds, you've moved 10 meters because 5 times 2 is 10. So that means that the base of our rectangle is just equal to v times t. So the magnitude of magnetic flux is equal to VBLT, which is option C. Next is part 2, which says, find the magnitude of the electromotive force induced in the coil. So the electromotive force is equal to VBL. You'll probably learn how this is derived when you study magnetic and electric fields. Because I think it's something that you are expected to just end up memorizing because it's pretty important and common. But basically, it's just the work done in moving a charge over the distance L, meaning it is in volts. And it comes from the equations for the electric force and the magnetic force, which equal to each other because our coil is moving at a constant speed v, so there is no net force. So these two forces are equal to each other if there's no net force. So the magnitude of the electromotive force is VBL, which is option B. Next is part 3, which says, find the induced current which flows in the coil. So voltage is equal to current times resistance, which means that current equals to voltage over resistance. And remember, what we just found in part 2, the electromotive force is in fact a voltage. So we just take the answer we just found and plug it in for V here, divided by R. So the answer to part 3 is VBL over R, which is option E. Next is part 4, which says, find the direction of the induced current which flows through the coil. So for this, you need to know the right-hand rule. So what you do is you take your right hand, point your thumb outwards. So point your thumb outwards and curl your other 4 fingers towards your palm. So it kind of looks like you're giving a thumbs up. Your thumb is the direction of the current, and the direction your other fingers curl is the direction of the induced magnetic field from the wire. So right here, this blue path right here is a current carrying wire, and these little arrowheads right here show the direction. So if you point your thumb out to the right on your right hand and curl your fingers. So like imagine you're following this part right here. So your thumb is pointing to the right and you curl your fingers. The direction of your curled fingers should match the direction of this green arrow right here, which is the direction of the induced magnetic field. The field induced by our coil needs to be opposite to the field it's passing through. Our question says that the uniform magnetic field is pointing from the back out front, which means our induced field needs to point down. So this example that I drew right here has the current going counterclockwise, right? It's going in this direction, that's counterclockwise, and its induced field is going up. So we need our current to go the opposite direction to make its induced field go down. So that means our current must be going clockwise, which means it's going from point A to B to C to D. And so the answer to part 4 is option A. Finally is part 5, which says, find the magnitude of the external force to maintain the constant speed V of the coil. So for this, you need to know that F is equal to BIL, which is the magnetic force on a current carrying wire inside a magnetic field. This can be derived, and perhaps your textbook will show you how, but as far as I know, it's not actually important to know how it is derived, and the physics behind it is beyond the high school level. It's just an equation that comes up often, since the concept of a current carrying wire in a magnetic field also comes up often. I know that probably sounds like a really weird niche thing, but it's actually like one of the fundamental topics that they teach in high school for magnetic and electric fields. But anyways, if you know this equation, then all you have to do is plug in the value for current, which we found in part 3, and we get the force is equal to VB squared L squared over R, which is option D. Next is the section 3 question, which says, at the surface of the Earth, the acceleration of gravity has the value g equals to 9.8 meters per second squared. The constant of universal gravitation is given by big G is equal to 6.67 times 10 to the negative 11 newtons meter squared per kilogram squared. Answer the following questions. So this is a question on gravitational forces and motion. First thing you need to know is this equation, which I think is the first thing you will learn when studying gravitational forces. Then you also need this equation right here, which says that small g, which is the acceleration due to gravity, is just the force of gravity, which is found by the first equation right here. These two f's are the same, divided by the mass of the object that the acceleration due to gravity is being applied on. Next, you need to know the escape velocity, which is equal to either the square root of 2 times big G times big M over R, or the square root of 2 times small g times R. And you can find one of these from the other by using this equation or I guess, yeah, using both of these equations, which I just introduced. Finally, you need to be familiar with centripetal force, and that it equals to mv squared over r, and also that velocity in uniform circular motion is given by 2 pi r over t, where t is the period and r is of course the radius of the circular motion. And then of course you need to know how to do arithmetic, which is basically what this question really revolves around. This question, at least in my opinion, is meant to test your nerves. You know, the exam is only 1 hour long, and they throw in this question, which requires you to spend quite a lot of time doing some math with very large numbers. Thankfully, it is multiple choice, so you don't need to be that precise. And by the way, that was not always the case. Or actually, no, it was always the case that multiple choice, but in the past, the multiple choice options were way closer to each other, meaning you have to be very precise with your calculations. Thankfully, they're not that mean anymore. So yeah, you don't need to be that precise, but still you need to make sure that you do all your calculations correctly while also not spending a very long time on it. In the case of this exam, this question replaced would normally be a kinematics problem. So I guess it depends on what you like more for if that is a good or a bad thing. I personally really suck at doing arithmetic on paper, and I often make errors. So I don't like this question. I think it's a bad thing that they replaced kinematics with this, but maybe you feel differently. But I guess the good thing is you don't really need to study for a question like this, other than, you know, knowing these formulas, which you probably should know anyways. Also, other than the basic steps of rearranging equations to solve for the thing you're looking for, these questions are really just straightforward math. So while I will show how to rearrange the equations and also some tips that I find to make the calculations easier, there's really not much for me to teach or explain here. So anyways, let's start with part 1, which says the radius of the Earth is 6.4 times 10 to the 3 kilometers. Find the mass of the Earth using the values of small g and big G. So we need to use our equations and rearrange them to find the mass of Earth. So firstly, notice that I slightly changed the force equation. So now we have a big M and small m. So big M is the mass of the Earth, while small m is the mass of the object that the Earth is exerting a gravitational force on, and vice versa. So we can plug the force equation into the equation for small g, and what you'll see is that these values cancel out. Small m and small m cancel right there. Right, and so what I did here is I took this formula for F and plugged it into this. And then, of course, this is F over M, so I just took the equation for F, multiplied it by 1 over M, and we get that small g is equal to big G times big M over R squared. Rearrange that, we get that big M, which again is the mass of the Earth, is equal to small g R squared over big G. And now we just need to start plugging in values. So firstly, notice that I converted the radius from kilometers to meters by multiplying by 10 cubed right here. Also, before continuing, notice that our multiple choice options all have 2 significant digits. And not only that, but the options are pretty far apart from each other. So you can get away with some pretty generous rounding during your calculations. Unfortunately, I can't really say what's, the correct amount of rounding. That's something that you need to figure out on your own. But anyways, next, I distributed the squared radius to get 6.4 squared times 10 to the power of 12. And I found that 6.4 squared is equal to 41. I did that over here. Or it's roughly equal to 41, right? It's actually equal to 40.96. But again, you don't have to be that precise given how generous the multiple choice options are. To get rid of the decimals, I multiplied 9.8 times 10 to get 98. And that, of course, meant that 10 to the power of 12 became 10 to the power of 11. I also did the same thing to the denominator. So now it's 10 to the power of negative 13. I multiplied 98 by 41, which is about equal to 4,000. I also took out the power of 10 and combined it with the power... I took out the powers of 10, and combined them to get 10 to the power of 24. So now we have 4,000 divided by 667, and what I did was I rounded that to 700. Of course, you have to be careful in rounding. By this much, you need to look at the multiple choice options and decide what a fair amount of rounding is. With that, I get, two of the zeros cancel out. I get 40 divided by 7 times 10 to the power of 24. 40 divided by 7 is roughly equal to 6. So I get 6 times 10 to the power of 24, which is option A. Also, you notice that if I never did this rounding here from 667 to 700, my answer would be a bit larger since I'll be dividing by a smaller number. But after option A, the next biggest option is option D, which is 2 times 10 to the power of 30. So, and clearly this rounding difference from 667 to 700 would not make a difference of over 6 orders of magnitude. So I know that, assuming I made no massive blunders, the answer must in fact be option A. So next is part 2, which says, an object can escape from the gravitational attraction of a planet if the object has a large enough speed. The minimum value of this speed is called the escape speed. Find the escape speed of the Earth. So for this, you need to use the escape velocity equation. I'm going to use this one since the other one has division, which generally makes paper math more complicated. And this time there's really no explaining. You just do the math. You might be worried at first since doing square roots on paper is pretty difficult, but thankfully it's not that hard if you manipulate the numbers a little bit. So after multiplying together the same way I did before, removing decimals and whatnot, you end up with something like this. You end up with something like this, 125 times 10 to the power 6, all under a square root. So firstly, you want to make sure that your 10 to the power of whatever has an even exponent. And that's because to take it out of the square root, all you have to do is divide the exponent by 2. So if I have 10 to the power of 6 here, then to take it out of the square root, I just make it 10 to the power of 3. And if we didn't do this, right, if it was, let's say, 10 to the power of 7, I had to take it out of the square root, at that point, it's not just 10 to the power of, it's 10 to the power of 3.5, and that's a lot more difficult to calculate than just 10 to the power of 3. So yeah, you definitely want to, that's probably your number one priority. Make sure you're 10 to the power of 6 or whatever it is, make sure it's an even exponent. So now we just have to find the square root of 125. So the easiest way, at least in my opinion, is guess and check. So 10 squared is 100. So clearly this square root is bigger than 10. So I'll check what 11 squared is. And after doing a little bit of calculations, I find that it is equal to 121. Now that's pretty close to 125. So we can round and say that this equals to 11. The square root of 125 is about equal to 11. So this is 11 times 10 to the power of 3. In scientific notation, that's 1.1 times 10 to the power of 4. And that is option C. Sorry, I was briefly interrupted. But anyways, next is part 3, which says the mass of Jupiter is about 320 times larger than the Earth, and the radius of Jupiter is about 11 times larger than the Earth. What is the ratio of the escape speed from Jupiter to that of the Earth? So we just found the escape speed of Earth. Now the question is giving us Jupiter's mass and radius, so we need to use this equation of the escape speed. So to find the ratio, we just need to find what they differ by. So the mass is multiplied by 320, while the radius is multiplied by 11. That means that the escape speed of Jupiter is equal to the escape speed of Earth times the square root of 320 divided by 11. Since if you took this, right here, all this, and divided it by the escape speed of the Earth, all this stuff would cancel out because that's just the same as what it is for Earth. And you'd just be left with the square root of 320 divided by 11. So we have 320 divided by 11, roughly equal to 320 divided by 10, which is equal to 32. So we need to find the square root of 32. 5 squared is 25, and 6 squared is 36. So the square root of 32 is somewhere between 5 and 6. So we'll say it's roughly equal to 5.5. And if you look at the multiple choice options, the only one that's anywhere near this is option B, which is 5.4. So, and yeah, again, you have to use judgment when rounding like this. In this case, because the other options are really far away from 5.4, this rounding I did right here wouldn't have made a big enough difference to accidentally get the wrong answer. But, that might not always be the case, so be careful. And next is part 4, which says a satellite moves in a circular orbit around the Earth. If the satellite's orbital period is equal to the Earth's orbital period, what is the radius of the satellite's orbit? So if you study gravitational forces, then you may have already learned the exact formula that you would use for this problem. But just in case, I will show how to derive it from some more fundamental formulas, namely centripetal force and circular motion. So the gravitational force on a satellite is in fact a centripetal force, since it is orbiting the Earth in circular motion. So that means that these two forces equal to each other, right? This is the gravitational force, this is the centripetal force. Then the linear velocity of an object in circular motion is equal to 2 pi r over t, where t is the period. Now plug that into the expression we just found, and we can cancel out some r's on this side, and then we rearrange this whole equation for r, and you get, and yeah, I'm not going to go through every single step of rearrangement. Assume you all know how to rearrange an equation. Once you do that, you get that r cubed is equal to big G times big M times the period squared over 4 pi squared, which means that r is equal to the cube root of all that stuff. So yeah, now we even have a cube root in our expression, which is pretty awful. But just like before, if you manipulate the numbers a bit, you can get an expression that's a lot easier to solve. So firstly, it says that the orbital period of the satellite is equal to the Earth's rotational period, meaning it orbits the Earth in 1 day. So our period is, 1 day, which if you calculate it, you'll find that it equals to 86,400 seconds. Now, I do a lot of arithmetic here. I'm not going to bother explaining it all since it's basically the same as before. I combine multiples to 10, multiply together, round with discretion, and so on. Also, right here, there's a star. You'll see that I made a pretty big math blunder. I forgot about this times 6 right here. I didn't include it. But, it doesn't really matter for me to fix that since I figure you all know how to do math, right? I'm not exactly teaching you guys how to do arithmetic right now. I'm just kind of showing you how to solve the question. So me actually solving it properly, having all the perfectly right numbers isn't really super important. It's really just an example of a mistake you might make if you're not careful and why this question is, kind of deceptively difficult or annoying in my opinion. But anyways, this time, since it's a square root, you want to get 10 to the power of a number divisible by 3, in this case 21. So we remove it from the square root and it becomes 10 to the power of 7. Then simplify this stuff inside the square root. So we get 4980 divided by 374. And here I finally had to do some long division because this fraction was a bit too difficult for me to figure out on my own. And so I got that the radius equals to the cube root of 13.3 times 10 to the power of 7. And remember, I made a math error earlier, so this is actually pretty wrong. But I figure you all know how to do math, so it's not really important to show you what the correct numbers would look like, just the process I used to find the answer. So we have 10 to the power of 7, which corresponds with options B and E. And you can be sure that the power on the 10 won't change, since the cube root of anything less than 1,000 will always be a single digit number. So we know that our answer is either 4.2 times 10 to the power of 7 or 6.4 times 10 to the power of 7, since those are the only two remaining possible options with the correct order of magnitude. So while you could use guess and check to find what our cube root equals to, you can also just check what 4.2 and 6.5 cubed are and see if either of them match what is inside your square root. So I found that 4.2 cubed is equal to 74.088. Of course, that doesn't match my cube root since I made a big mistake earlier, but I was actually still able to guess the right answer with some luck. This isn't really valuable information for this question, so you could probably skip this, but maybe my thought process can help you guess the right answer as well if you find yourself in a similar situation. So to start, notice that options A and D are immediately impossible. They absolutely cannot be correct. Part 1 says that the radius is 6.4 times 10 to the power of 3 kilometers, which is 6.4 times 10 to the power of 6 meters. So it can't be A, since the orbit of our satellite can't have a radius smaller than the radius of the planet it's orbiting. And it can't be B, since it can't be orbiting literally on the surface, okay, right? D, not B, since D is just the same as the radius. So the smallest possible option is option B. Now my cube root, sorry, am I getting these letters correct? Yeah, the smallest possible option from the options given is B. And then the only possible options are B, C, E, and F. So my cube root was 13.3, which is obviously a lot smaller than 74. But what I can say is that my answer is smaller than the smallest possible answer. Therefore, it's right to assume that I made a mistake that made my answer smaller than it should be. So now I have to guess between options B, C, E, and F. Now, presumably the mistake I made could not have been so big as to change the exponent on my 10. That would either require that I messed up when combining all the 10s, or that whatever I had inside my cube root was supposed to be a number greater than 1,000. Now, maybe I did in fact make those mistakes, but as a reasonable guess, I will say that I didn't. This is an especially reasonable guess to make if you went through your previous steps and couldn't find the error. Because the thing is, if you can't find it, then it probably wasn't, that massive or obvious a mistake. So the correct answer is probably B or E, since C and F have a higher exponent, and it's pretty unlikely I could have done that. 4.2 cubed is 74, while if you found 6.4 cubed, it's 262. But I, of course, have 13, right? That's what I found earlier incorrectly. So again, I choose to assume that my mistake isn't that large, meaning if that is true, then the actual correct answer is 4.2. So I chose option B, and that happened to be correct. Now, obviously, this is not foolproof. And the real correct way to find the answer would be to go through your steps, locate the mistake, and fix it. But of course, this is a difficult exam with a time crunch, so you might not have the option to do that. So maybe my process of, guessing the right answer could be helpful to you. So next is question 4, the section 4 question, which says, 1 mole of a monatomic ideal gas is taken through the cycle shown in figure 4. In the process AB, the gas, I'm not even going to say all of it, you can just look at the diagram and see. The gas has a molar specific heat at constant volume, C sub V equals to 3R over 2, with R the universal gas constant. Answer the following questions. So for this question, you need to know that thermal energy changes in a system, or specifically in a system with thermal energy changes in a system equals to the change in internal energy plus the work done. That's this equation right here. Because this is an ideal gas, there is no force of attraction between the particles, so the change in internal energy is equal only to the change in the thermal energy of the particles. And for a monatomic ideal gas, that is just equal to 3 over 2 times pressure times the change in volume, or 3 over 2 times the change in pressure times the volume. The thermal efficiency of a thermodynamic cycle is equal to the net work done divided by the thermal energy transferred in, and work is equal to pressure times change in volume. By the way, the question mentions the molar specific heat. So this might be unsatisfying to hear, but I never learned about what this is and I don't exactly understand it. But what I do know, which is important, is that a monatomic ideal gas will always have a molar specific heat at a constant volume equal to 3R over 2, which is what the question gives. And in all of the MEXT physics exams that were given in practice, or as practice, the thermodynamics questions are always about monatomic ideal gases, meaning that the 3R over 2 value stays the same. And that means that these equations here will always work, because technically these equations are specifically for this situation. When I learned high school level thermodynamics, only monatomic ideal gases were ever talked about. So as far as I can tell, that's the only thing that a high schooler would be expected to know, meaning you can probably safely just use these equations for any thermodynamics question on the MEXT exam. But I do not know that for certain. Maybe the curriculum has changed. Maybe the past exam just happened to avoid those things. But I'm pretty sure you can safely assume that these equations will always work for a thermodynamics question on the MEXT exams. But just in case, here's a more general formula for the change in internal energy of an ideal gas. If you used this equation for this question, you would still get the same answers that I got. So maybe if you want to be extra safe, you can use this formula instead. But if your question deals with a monatomic ideal gas, then all these equations will do just fine, and they're a bit easier to use. So now you can start with question 1, which says, find the thermal energy transferred into the system in the process AB. So the thermal energy transferred into the system is, of course, equal to the change in internal energy plus the work done. Work is pressure times change in volume, and in the case of AB, the volume does not change at all, so therefore the work is just equal to 0. So we only need to find the change in internal energy. So it's 3 over 2 times the volume, which is V sub O, and for process AB, the volume is of course constant, or consistent, I should say, times the change in pressure, which is 4 times P sub O minus P sub O. And then you simplify, and you get that it equals to 9 over 2 times P sub O times V sub O, which is option E. Also, from now on, I'm just going to say P and V instead of P sub O and V sub O to make things a bit easier for me and for you. So next is part 2, which says, find the thermal energy transferred into the system in the process BC. So this is basically the same thing as part 1, only now the volume does change, so we do have work done. It's just equal to the pressure times the change in volume, which is 12 times PV. We calculate the change in internal energy the same way as part 1, and we find that it equals to 36 over 2 PV, which is of course just 18 times PV. And then we combine the work and the change in internal energy together, and we get the thermal energy transferred is 30 PV, which is option C. So next is part 3, which says, find the net work done by the gas per cycle. So to answer this, you could find the work done in every step and combine it in order to find the net work. It wouldn't even take that long since we already found the work for BC, and the only other step that does work is dA, since CD, the volume, does not change. But if you happen to know this trick right here, you can answer it a bit faster. The net work done by a loop like this, right? We have a loop going from A to B, B to C, C to D, and D back to A. So the loop on a chart like this, where you have volume and pressure, is just equal to the area of the loop. And our loop is just a square, so finding the area is really easy. One side length is 3p, and the other side length is 3b. So the area is 9pv, and that is the net work done, and that is option F. Now last is part 4, which says, find the thermal energy of the cycle. So the thermal energy of a thermodynamic cycle like this is equal to the net work done divided by the thermal energy put in. So we just found the net work. And we also already found the thermal energy put into the system in processes AB and BC. An important thing to realize is that that's all the thermal energy put into the system, because both processes CD and DA do not gain more thermal energy, they lose thermal energy. In process CD, the pressure goes down, and in process DA, the volume goes down. And since we always just have 1 mole of gas, that means the temperature must also go down. So we already have all the thermal energy put in. It's just AB plus BC, which we found for parts 1 and 2. So we combine those two together, and we divide by the net work. And we take the net work and divide it by the total energy put in. P and V cancel out. And so once you simplify the fraction, you get that the answer is 6 over 23, and that is option D. Next is section 5, which says, a sound wave travels in the positive x direction. As the sound wave propagates, the air pressure P changes above and below the normal atmospheric pressure, P sub 0. At x equals to 0, change in pressure is equal to P minus P sub 0, varies time dependently in a sinusoidal manner as shown in figure 5-1. The horizontal axis represents time t. Answer the following questions. So this is like barely even a physics problem. Technically it's about a sound wave and pressure, but the questions can easily be answered just by knowing a little bit about how waves work. Specifically, oh, sorry, I should have already scrolled down here. Specifically, you need to know that the period of a cycle or a wave is equal to 1 over the frequency, and that the speed of a wave is equal to the wavelength times the frequency. Also, the definition of a period, at least for a wave, is the time between two adjacent peaks or troughs. Technically, there's a part of this question where you sort of need to know how air pressure works, but it can also be answered just based on intuition really easily. By the way, I just want to mention that while the physics exams are probably considered to be the easiest of the MEXT undergraduate exams, this one in particular is probably, especially easy. You're pretty blessed if you get an exam like this. I mean, section 1 was probably harder than normal, and section 2 is a bit weird for someone that isn't very familiar with magnetic field stuff. But in general, they made this one quite easy compared to the rest. So if you don't feel like studying, then instead you could just pray that you get an exam like this. But also, I mean, this is relative to the other exams. So, don't feel bad if you're struggling with this one. It is still a difficult exam. It just happens to be relatively easy compared to the other MEXT undergraduate physics exams that they give for practice. But anyways, let's begin with part 1, which says find the amplitude and change in pressure. So for this, you just look at the wave and see that its peak is at a value of A and its trough is at a value of negative A, meaning the amplitude must be equal to A, which is option C. If you want to be extra sure, then you can use this equation for finding the amplitude, which is the maximum minus the minimum divided by 2, and you'll find that it still just equals to A. So our amplitude is equal to A. Next is part 2, which says find the period of the oscillation. So for this, we can use the definition of the period, which is the time between adjacent peaks and troughs. The question does not give us anything about two adjacent peaks or two adjacent troughs, but it does give us the time it takes to get to a peak, and then the time it takes to get to the trough immediately after it. And crucially, the time from a peak to a trough is half the time from a peak to the next peak. Hopefully that makes sense, right? You have two adjacent peaks, and it takes some amount of time to get from one to the other. In half that time, you will get to the trough in between them. So that means our period is 2 times the time between t sub 2 and t sub 1, right? Because t sub 2 is a trough and t sub 1 is a peak immediately before it. So that means that our period is 2 times t sub 2 minus t sub 1, which is option C. Next is part 4, which says a snapshot of, next is part 3, which says the speed of the sound wave is v, find the wavelength of the sound wave. So for this, we use this equation to find the speed of a wave, and we rearrange it to find the wavelength, which is velocity over frequency, right? And then and period is equal to 1 over the frequency, so the wavelength is equal to velocity times the period. We just found the period in part 2, so this just equals to, this period times velocity, which is 2v times t sub 2 minus t sub 1, and that is option A. And next is part 4, which says a snapshot of the change in pressure as a function of x at a certain time t is shown in figure 5-2, which is the highest density point. So this is a question that requires a tiny little bit of intuition. The question asks for the highest density point. Well, hopefully you can agree that the higher pressure correlates to higher density. So we want to find the point with the highest pressure. And the question makes it really easy for us. It literally says that the y-axis is change in pressure, right? If you look at figure 5-2, the y-axis is labeled as a change in pressure. So we want the point which has the highest change in pressure, which just by looking at the graph is clearly option D. And that is the answer to this part of the question. So that is it for this exam. I hope you found this helpful. If you have any questions about this exam, leave a comment and I will try to help. And if you are writing the exam soon, then good luck and have a good day.